Hello, everyone. My name is Laura Villalobos. I'm WiCyS Community Manager, and I would like to welcome you to this WiCyS webinar with AT&T Cybersecurity. But before we start, I'd like to introduce you a little bit more about the WiCyS organizations. So we often go by our acronym WiCyS, as in We Sisters, because that's exactly what we are, a global cyber sisterhood. We are a 501c3 with over 8.7 thousand members in 70 countries. WiCyS is a premier organization with a global reach dedicated to bringing together women in cyber. Our mission is to recruit, retain, and advance women in cyber. All of our mission programs and initiatives are made possible by our strategic partners. We have our professional affiliates, student chapters, equity advocacy committee, mentor-mentee programs, speaker bureau, job board plus, and so much more. You can view our training initiatives on our website at www.wicsys.org to learn more about the different ways to get involved beneath the WiCyS organizations. We all our wonderful initiatives to our strategic partners, our tier one partners being Alchemine, Amazon, AT&T Cybersecurity, Battelle, Bloomberg, Carnegie Mellon University Software Engineer Institute, Cisco, Ford, Fortinet, Google, Lockheed Martin, Microsoft, Optum, Sandia National Laboratories, and Sentinel One. And a friendly reminder to ask questions. We have the experts here today, and we look forward to hearing from you. And if you haven't done so already, please subscribe to the WiCyS newsletter at wicsys.org to stay up to date on any upcoming events and trainings. And with us today, we have AT&T Cybersecurity on the topic of unleashing AI-powered detection and response in a hybrid environment. So I will take it over.
Hi, everyone. Tanya Lancaster here. I am so happy to be with WiCyS today and be presenting for you all. As mentioned, I'm going to be speaking to the topic of how AI is shaping threat detection and response and the work that's being done in security operations centers globally. As we all know, AI is reshaping fundamentally how businesses across the board are doing their work, how they're communicating, how they're conducting business. But techniques for AI have been around for more than a decade within cybersecurity. We have been using techniques like machine learning for over 10 years, but we're definitely seeing the increase use of those across the board, not just in security operations, but we're seeing the increase in use across all of security tooling. So as vendors bring new AI techniques to market, we're going to see an explosion of AI, I predict, in the next few years. So happy to be talking to you guys about AI today and its impact on security, in particular on threat detection and response. A little bit about myself. My name is Tanya Lancaster, and I lead the product marketing, research, and customer insights group within AT&T Cybersecurity. So for those of you who perhaps don't know, AT&T actually has a very large managed security services business. In fact, we are one of the top 5 global security services providers. And that means that we are serving customers all the way from mid-sized companies all the way up to very large enterprises and federal agencies. And we're helping them with managed services. So we're managing the security across a variety of things. And that includes everything from managed network security, so managed firewall, managed access solutions, all the way through to DDoS and up into managed endpoint security and managed detection and response. We have an entire suite of services that we deliver to customers through 9 global network and security operations centers and a full operations staff of security analysts, threat researchers who are managing that. And it's in those 9 global operations centers, as well as within our own threat intelligence unit, that we actually are using AI in a significant way. And so that is what I'm here to speak about. So just a little bit of agenda. We're going to talk about the differences between AI and machine learning and other techniques that fall under the category of AI. I think AI often gets used interchangeably. And I think it's important to understand that AI, what it is and what falls under it. We're then going to talk about some of the challenges that are driving the use of AI within security operations for threat detection and response. And then we'll jump into some very specific use cases. I'll talk about, for example, how threat intelligence units are using AI for threat intelligence curation. And then we'll jump into some of the actual use cases within the security operations itself. So how are threat analysts using AI in their day-to-day work and in their reporting back to customers? So that's kind of what we're going to cover today. So with that, let's jump into just a little bit of a discussion to set kind of a foundation for the rest of this presentation on when I say AI, what I mean and how that differs from the techniques that fall under AI, such as machine learning. So as I mentioned, if you think about AI as a broad category, and under that broad category, there are dozens and dozens of techniques, and those techniques are used to automate human processes. So to teach machines certain processes and then make those processes automated, but also then to teach machines the ability to learn on their own so that they can basically learn without being programmed. And this includes under AI, which is, again, we all know that AI is impacting businesses across the board with many, many different use cases. Within cybersecurity, we have been using AI and specifically supervised and unsupervised machine learning for over a decade. And those techniques are evolving. So under the broader umbrella of AI, you have literally more than a dozen right now. I went to Gartner and I researched, and I found more than a dozen different techniques that fall under that category of AI that are right now being used in cybersecurity. So this includes things like supervised, unsupervised machine learning. It includes things like large language models, model hubs, open source LLMs, domain-specific generative AI models. You probably have heard quite a lot in the news lately about ChatGPT. So generative AI, which is really an evolution of multiple AI techniques. So again, under the broad category of AI, you have many, many different techniques. Some of the ones that have been used foundationally and quite a bit, and I think we're fairly mature in our use, are unsupervised and supervised machine learning models. So when you think about unsupervised and supervised machine learning models, there's really two distinctions. A supervised machine learning model is a technique that data scientists use to train algorithms for things like pattern recognition, data classification, and prediction. So what happens is the data scientists take known information, known data, they label it, and they feed it into an algorithm, and they also feed it in desired outputs. And they basically train that algorithm based upon that known labeled data. And so what that algorithm can then do is it can focus on classification and predictions based upon those known data sets. So for example, we've been using supervised machine learning for quite a long time in next generation antivirus or other security tools such as user entity behavior analytics. And this is because the industry has a large access to a very large data set that we already know about. So we have a very large databases of known malware files, known signatures, and in fact, even organizations individually have their own databases of these known data sets. Our threat intelligence unit, Alien Labs, has been collecting data on malware, has been collecting data on signatures and other things for years, known malicious URLs, known command and control servers. And so we have our own data set, decades of data that we can then use, and we have known information about that data. So we have, for example, take the example of data such as URLs. We can mark URLs as suspicious, benign, or unknown, and then we can feed that into an algorithm, and then we can train that algorithm to recognize variations on that URL and or to make predictions based upon the information that we're feeding in. The important thing about supervised machine learning and understanding what it is that it's been around for a very long time. It's a proven technique, it's a proven model, and it's using known labeled data that human beings are labeling and inputting and training and validating and fine-tuning. And because of that, because it's been around and because we're using known model sets, it's probably the most used AI technique to date. But that is changing. You're seeing the rise of things like unsupervised machine learning models. So unsupervised machine learning models is an approach in which data scientists use a collection of unlabeled data sets. So they're basically using data sets to start to train those models, but they're not labeling that data. And sometimes unsupervised machine learning is also evolving from a supervised machine learning model. So not labeling the data set. So what happens is the algorithm creates a set of classes that it thinks are, for example, a baseline of normal behavior. And then having that baseline, the models can then find patterns that deviate from the norm. The important thing about whether it being a supervised or unsupervised model is that the more data the algorithm is fed, the more quality data the algorithm is fed, the more accurate the answers are going to be. And then you also have to always fine tune, validate, and train those models. So it's not a magical thing that happens where all of a sudden you turn on an algorithm and everything's ready and set to go. No, there's a certain level of training that has to be done. There's a certain level of fine tuning. And it also depends on the data set that you're using. The quality of the output that you get from any AI technique is highly, highly, highly dependent on the data that's being inputted and the quality of the data, as well as the data scientists who are training those algorithms or creating those algorithms. So again, unsupervised models are not trained ahead of time. And because of that, there tend to be more false positives, and the results need to be frequently validated, and those need to be fine-tuned. And that takes more time typically than the supervised machine models. And in fact, within our own SOC, we create models, algorithms for UBA analytics, for user entity behavior analytics. So UBA use cases, and we're training on our customer data. So we're looking at what is the baseline normal behavior of users within a particular organization, and how can we detect on anomalies outside that baseline normal. But in order to do that, we have to input a bunch of data about the customer's environment, how those users are using applications, how they're interacting with that environment. And that takes anywhere from 3 to 6 months for us to be able to fine tune those. So again, I mentioned that there are other techniques under AI. We also have things like large language model, which is, again, another technique that falls under AI. It analyzes massive amounts of data that it can massive amounts of content that it can understand, it summarizes, and then it generates and predicts new content. So you guys all, I'm sure, have heard of ChatGPT. ChatGPT is a model out there that is a hybrid using multiple different systems. And that's one of the things that we're seeing with the evolution of AI, not just within cyber, but across the board, that where we used to be pretty much using single models, what's happening now within organizations is that they're using multiple models and they're using them together. So again, go back to what I said earlier, where you've got to think about AI and its use cases and its techniques as a system that involves data, that involves people training that data, writing those algorithms, that involves the interaction with other techniques, AI techniques. And all of that system requires governance and monitoring, and requires upfront work, because without that, the quality of what you're going to be outputting is going to be impacted. So talking about what are those challenges that security operations teams are facing that is really driving the use of AI and machine learning, and why it's become such a critical tool. So we all know that threat actors are continuing to shift their focus. They're continuing to exploit a broader set of vulnerabilities across the attack surface. And the attack surface of organizations is really, if you think about it, as all the ways in which an organization can be attacked, all those attack vectors, all the endpoints, all the network paths, all the vulnerabilities, that comprehensive attack surface in terms of any way an attacker can get in. That attack surface for every organization globally is expanding exponentially. And it's becoming more diversified because we're seeing an explosion of endpoints, including both traditional endpoints as well as traditional endpoints, meaning things like your mobile phone, your laptop, your desktop, a server. But also now, as we move into the cloud, you're seeing other things like virtual machines or containers or fileless applications. But also think about, as we continue to move to the edge, you've got edge devices, IoT devices. We're also seeing the convergence of OT, operational technology. So that's the technology that supports our critical infrastructure, things like ICS and SCADA, converging with IT systems. Those used to be air-gapped. They're not. So all of this is driving an explosion of data that we have to monitor across the attack surface and analyze. In addition, threat actors themselves are using AI to speed their ability to create new malware variations, to speed their ability to build new infrastructure, to create new domain names, and to adjust their TTP. So not only are we seeing the explosion of information within our internal systems that we're monitoring, we're also seeing that fast-moving threat actor changing their behaviors and being more efficient using AI themselves. And in fact, we are the only industry in which, as fast as we innovate, we have a criminal on their other side who's using many of those same techniques to innovate as fast or faster. So basically, this becomes a massive data problem for security professionals. They've got hundreds of different data sources, from network traffic to endpoint to cloud workloads to IoT devices. And they need to take that ingested data. They need to then correlate that data with real-time or near real-time threat intelligence about how threat actors are exploiting vulnerabilities in the wild and what tactics and techniques that they're using. And they have to correlate those two things. There's so much data being generated right now that it's simply impossible for security teams to analyze it fast enough. And it goes beyond the scope of human efforts that we have traditionally used in security operations to detect, prioritize, investigate, triage, and respond to alerts in any reasonable amount of time. It's simply surpassed the limits of our human ability. And then you add on top of it the fact that security operations teams are often understaffed, or they're finding it difficult to get experienced people into their security operations centers or onto those teams to be able to do this kind of analysis and detection. So they need help. They need a fast way to sift through all that data. They need a faster way and more effective way to correlate that data with threat intelligence so that they can identify threats effectively and quickly, so that they can minimize false positives, do forensics quickly, contain or triage threats, and respond effectively. And then in addition, there are other manual processes they need to speed. Every time an incident happens, there's a reporting action that needs to take place that describes the incident, what actions were taken, what was impact. So in a lot of ways, we can use AI to help speed those manual processes. So it's making a monumental impact on how we are working within security operations generally. So I'm going to go into some of each one of these areas in detail, but some of the high-level areas where we're seeing an impact is faster validation and enrichment of threat intelligence. I'll talk a little bit more detail about what that means. We're seeing faster real-time detection and prevention and mitigation, faster incident response, and faster recovery, because AI can help us in a lot of those response actions. It can actually help us in making recommendations on what needs to be done for recovery. It can assist with access control and authentication and monitoring and managing that for any anomalies. It can assist with compliance and reporting and things like that that we have to do as part of our job in security operations. So as I mentioned, there's many, many different use cases for AI across cybersecurity organizations. I'm going to go into a couple in how we're using it within our own threat intelligence team and within our own security operations team at AT&T. But this is by no means a comprehensive list of all the uses of AI. And even as I sit here and present, our teams are looking at what are additional use cases we can bring on. So let me first start with how we're using AI to power our threat intelligence validation, our threat intelligence curation. There's a couple of ways. So as I mentioned, we've been using machine learning within cybersecurity for supervised machine learning for a very long time. And in fact, our threat intelligence unit has been using supervised and unsupervised machine learning as part of our threat intelligence curation for over a decade. We have, as I mentioned, a lot of known data that we store around threat actors, their behavior, their infrastructure, their techniques, malware variations, and more. And we've collected petabytes of data. We have a ton of historic data that we can train new algorithms on. Some of the areas that we're doing some of that work in, for example, is we're using algorithms to validate, enrich the indicators of compromise that we're using in our system. So think of indicators of compromise as kind of those front line of defense that detect something is going on in an environment. It's by no means a comprehensive set of intelligence. Threat intelligence is multi-layered, using indicators of compromise all the way up to understanding threat actors, techniques, tactics, techniques, and procedures. But if you think of IOCs are a very fast way to do kind of first line of defense identification. We have what's called the Open Threat Exchange, which has been around for over 10 years now. And it's actually one of the largest open threat intelligence communities in the world. We now have 250,000 users, including security vendors, who are using OTX to pull threat intelligence into their system. And one of the main things they use it for is to extract indicators of compromise automatically into their systems from a variety of resources. So OTX is free to use. There are many kind of features to it, including being able to extract IOCs. There's other features like you can validate malware, which makes it very sticky. So that's why our community has grown so large. So we have security researchers, IT folks, actively using OTX to extract indicators of compromise information from things like blogs, websites, PDFs, emails, text files into the platform. So they extract this. There's a very simple tool, is drag and drop into the OTX platform. From that platform, they can then automatically integrate those IOCs into whatever system they are using for detections, and it becomes an automated process. So the way we're using machine learning in that capacity is we're using it to speed the extraction of those IOCs from those different resources, websites, blog posts, PDFs, etc., or emails. And we're also using it to validate that those IOCs are true indicators of compromise. And we're using it to automatically enrich those IOCs with additional information that's already known by our Alien Lab systems. So for example, we may get an indicator of compromise that comes in that we know is associated with a specific malicious URL that's associated with a specific threat group, and there's information about that that we can automatically associate with that. We also can associate it with MITRE attack IDs. We can associate it with tags for malware targets, or like such as this targets endpoints or servers or OS systems. So we're using machine learning to automate that extraction of those IOCs, to speed it, and then to enrich that information so that it can be more of use in detection. Other ways that we're using machine learning in the curation of our threat intelligence, we're using it to be more accurate and more predictive and faster in identifying malware variations. So as we all know, there are whole malware families that have been out there for a long time. If you think about TrickBot, a banking Trojan / worm, has been around for years, and it's still being used very actively in the wild. And it's got dozens and dozens of variations that attackers can make use of, and they can make very, very small adjustment and then re-release that into the wild. Well, we can use machine learning, and we are using supervised and unsupervised machine learning to cluster malware. So if we see something coming into our systems and we're not quite sure what it is, we use machine learning, unsupervised machine learning, to identify, is this got similar characteristics? Does it show similar behaviors to what we already know about certain malware families? And thereby, we can more quickly classify it. We can more quickly get information about that and then move on that information. So for example, we can also, if you take the example of TrickBot again, and we see TrickBot is often associated with Ryuk ransomware, which is one of the most active, what has been one of the most active malware families for financially motivated attacks. So those two are often paired together. So if we see some variation of TrickBot or other thing coming in, we can then immediately make those associations to other malware families or other types of malware that have often been associated with it in campaigns or threat groups that we know are using this. We can also use machine learning for things like detecting common line obfuscation, a technique that threat actors are using to hide from security controls. We're also using machine learning to identify threat actor infrastructure. So for example, threat actors use domain generation or DGA algorithms. And these are basically algorithms that help them generate a large list of domain names. And those domain names are used to provide malware with new domains to continuously evade security. We can use machine learning to predict the use of those algorithms, but also to classify and associate known domains with certain malware or threat groups. So that's how there are just a couple of examples of how we're using it in the curation of threat intelligence. And of course, that threat intelligence and being able to update threat intelligence quickly and in near real time is critical for the SOC team to be able to then detect and respond, because that threat intelligence gets fed into a threat detection and response platform. So for us, we use what's called USM Anywhere. It's the platform that our security analysts within our SOC teams run our service on top of. We feed our threat intelligence that's been curated into that platform. It gets continuously updated. We also use machine learning to give feedback into our threat intelligence. So it's a circular cycle. So we're constantly enriching and updating the threat intelligence as it gets fed back into the USM platform. And as USM does detections and investigations on events and alarms, and we get more information, we're feeding that back into the threat intelligence. So how are we using a couple of examples of how we're actually using AI within the platform itself? So I talked about how we're using it to curate threat intelligence that's then getting fed into the platform. But then how are we using AI within the platform itself to make the job of our SOC analyst and those teams easier, more efficient, more effective, and faster? So again, there are a lot of different use cases, and this varies by organization. But in general, I think we can make a general statement that AI has become critical to helping the SOC team optimize their operations. And they do this by automating workflows, saving time and some of those human tasks like reporting and gathering of information that in the past has been done by the analyst teams, but now can be done by AI. Enabling faster detection, faster investigation, faster collection of information, faster response, and reporting. So I'll give you a couple of examples. In terms of reducing the workload for analysts, we can save fundamental, valuable analyst time, but by enabling the automation of those manual repetitive tasks. So think about things like playbooks, or the day-to-day monitoring that a tier 1 analyst is doing day in and day out. A lot of those manual tasks can be automated and can be done more effectively with the use of machine learning. Other areas where we're seeing the use of AI help with workflows and stuff. When an analyst gets an incoming alert, there's repetitive actions that they take to investigate, to first validate, is this a true alert or is this a false alarm? They then have to collect a bunch of information about that in order to conduct their investigation so that they can determine, okay, what are we looking at? What are we seeing? And then to make recommendations for how to respond or to do automatic response actions. So we can use machine learning to quickly automate and more effectively gather a lot of that critical contextual information the analyst needs in the event of alert. Or we can use machine learning in order to immediately identify false positives. You'd be surprised at how much time security analysts are spending going through alarms that end up being false positives. So by using machine learning, we can take a lot of that work that they're doing manually off their plate. And that makes their job, it takes them away from those manual tasks and allow them to focus on higher, more complex processes. We can also use machine learning to prioritize alarms for remediation, to take in a bunch of contextual information from the environment and say, okay, you've got 2 or 3 alarms coming in. Here are the ones that you should deal with first because these look like they're putting the organization most at risk. We can use machine learning to, again, boost intelligence. So when an analyst or threat hunting is looking at alarm, machine learning and AI can actually be used to gather the contextual information or the threat intelligence. The complementary threat intelligence is going to give them the information about that alarm so that they can do a faster investigation and make faster recommendations about actions to take. And then we are also using AI and machine learning to reinforce our threat detection tools. So again, we use it for augmenting signature-based methods of threat detection. I mentioned earlier how we can use it to make predictions on signatures. We're using it to alert on behavioral anomalies, I can't even say that word, anomalies within the system. So things like bad traffic or somebody logging into the system at a time that is inconsistent or at a location that's inconsistent, using it again to eliminate false positives. And then again, using it in the analysis of events for incident data gathering. So in that way, at a very high level, those are some of the ways that we're improving workloads within the SOC. One of the things that it's really important to note that as our analysts are working within the SOC and taking advantage of these algorithms, they have to have a way of giving feedback to the systems. So we have, for example, specific ML-specific dashboards that allow our analysts to give feedback in order to adjust thresholds or to fine-tune validations on those algorithms. So it may be that a customer is we're seeing too many alarms in a customer because we don't have the threshold fine-tuned enough. So the analyst can go in there and make those kinds of tunes within the dashboard. And that is really, really important. So one of the areas where we're using specific areas where ML has been used for a very long time is within user entity behavior analytics. So there are a lot of use cases for this. So if you think about UBA as looking across a system and understanding what is the baseline of what our users and entities, so we're talking both machine and humans logging into the systems, accessing applications, accessing files, doing that day-to-day work that we all do. UBA is really looking across the environment and saying, okay, what is the baseline for normal? Not just of the organization itself, but really of individuals within that organization. So we can use machine learning and we can use AI in order to establish that baseline for an organization and then be able to detect on anomalies that go above that baseline threshold. And so some of those areas that we can do that in are looking at, let me just jump to the next slide. Looking at, for example, credential compromise. So A large number of breaches are attributed to stolen credentials, and this is a particular problem in the cloud. Cloud credential compromise is responsible for a significant number of attacks. And we can use machine learning models to basically supercharge UBA capabilities for detecting compromised credentials within an enterprise, especially within cloud applications. And this has become one of the most effective uses within our own organization. So what happens is the model analyzes multiple parameters or uses multiple parameters or features around log activity to identify those outliers, to identify what is baseline, and then be able to then identify what are the outliers of anomalous behavior. And so those parameters could include a variety of things like geographic location. It could include timestamps. It could include what type of device the person is using. It could include ISP data, IP data, authentication more. I mean, there's a variety of things that we can use. So for example, if you have a user within an organization that you know as a baseline of normal, that they log in from the US in California between the hours of 8 a.m. and 6 p.m., and they typically are using an iPhone or a MacBook, and then all of a sudden you see that user logging in from China using a Windows device, you know something's wrong. Well, machine learning can be used to detect that more quickly and to bring that to the attention in a real-time fashion to SOC analysts. Another area where we can use it is within lateral movement and understanding and detecting anomalous lateral movement within the network. So when a threat actor infiltrates a network, one of the things that they can do is start moving laterally across that network. And so we can use machine learning algorithms that are fed authentication logs from different services across the network. And we can observe lateral movement scenarios such as a Windows RDP or context data or source destination host name, those kinds of things, or Active Directory domain names. We can use that kind of information to detect, is there weird anomalous behavior of movement within the network? And then we can do that automatically in real time and raise that to the attention of the SOC. Another use case is suspicious execution. So we can use machine learning algorithms to identify anomalous executions. So using things like host name, file path, command line, data structures, and we can compare across the organization. If we see suspicious execution in one place of the network, we can then use that as a baseline for comparing across the entire system to see, okay, where might there be other suspicious execution within the network? And we use machine learning for that. And then one last example, data exfiltration. Again, another big use within our organization, an effective use of ML. So we can integrate with file storage services and enable things like, are we seeing early detection of file access? Are we seeing a weird number of files being extracted from the environment by a user? Or are we seeing somebody accessing files that they shouldn't have access to? Are we seeing massive file deletions? So there's a wide range of use cases around data exfiltration that we can use to be detecting anomalies. Very effective use. So in closing, obviously, as I mentioned before, there are many different use cases within security operations, but also within the broader security landscape. So for example, on the network side of things, we are seeing the use of AI for things like understanding if processes or security tooling is running effectively, or for identifying if application performance is running as it should, and then automatically self-healing to identify the problem if an application isn't running effectively, and then to be able to self-heal and fix the problem. So there's a lot of use cases across security in general. But specifically, even just within threat detection and response, this is one of the most effective areas where we're seeing AI growing explosively. And as I said when I opened up, I think we're going to see even greater number of techniques and an even greater number of use cases in the next few years. I think we're in a period of real explosive growth in AI. We've been, again, using it for many years in cybersecurity, but I think some of the advances that have been made with supervised machine learning, unsupervised machine learning, moving into neural networks, which are kind of supervised machine and unsupervised machine learning, taking to the next level of understanding more complex patterns, and these hybrid models and techniques where you're using multiple AI models together, like with generative AI, I feel like we've hit a tipping point. And so, and we have to, because as I mentioned, as much as we are using AI within our own protocols and our own security tooling to protect the organization, our attackers are using it in their way to be able to increase the speed, the efficiency, and the efficacy at which they launch an attack, relaunch an attack, until they're able to actually get into our systems. So kind of net in closing, there's no way we've reached a point within security operations, threat detection and response across the environment, whether it's endpoint detection and response, network detection and response, detecting in clouds. There's no way, with all the data that we have to monitor, that we have to pull in and analyze, there's no way we can do that with human beings alone. We've hit a point where AI has to be used. I will also add that AI is not used in isolation just in of itself. We are using it, and many organizations are using it in conjunction with different forms of analytics, different forms of automation, many different systems that they're running those detections through, or they're running that threat intelligence through to do that validation, to do that enrichment. So it's not just AI alone, but we'll continue to see the evolution of these things. And I'd like to just close with reiterating that because of that, AI cannot be considered alone. It cannot be considered in isolation. As we think about the use of these techniques moving forward, they have to be thought as part of a larger system. And again, that system includes the data that we're ingested, good data in, good data out, bad data in, bad data out, the processes that we have in place, the way we're connecting those systems together, the technologies that we're using, and the people. Who's actually creating those algorithms? Who's fine-tuning those algorithms so that we know that they're accurate? And all of those things require a level of governance that I'm not sure the industry itself has a handle on. There's quite a lot of research out there right now within Gartner, within IDC, other analyst firms, that's really looking at, okay, what are the risks of using AI within our organizations? What have we not considered? And how should these things be governed in order to ensure that we don't compromise the very organizations we are trying to protect, and that we're not putting those organizations more at risk? So we may have some questions coming in. I'm happy to answer questions. I may not be able to answer them all, and if I can't, we will certainly find the answers for you. I will also reiterate that we have a white paper called Data Analytics and Cyber Threat Intelligence, How Automation, Analytics, and Machine Learning Improve and Accelerate Threat Analysis. We can make a link to that white paper available for anybody who's interested after. I think it gives a really good overview of how AI has traditionally been used in threat intelligence specifically. And we're probably going to be updating that to bring in some of the things, additional things I've been talking about today. So thank you, everyone. Are there questions? Oh my gosh, there's a lot of questions. All right. I will start reading out some of these. What is your opinion on the evolution of AI ML change for SOAR products from IBM Maria? Oh, that's from IBM. So for those of you who don't know, SOAR products are security, orchestration, analytics, and reporting. It's a category that evolved about 10 years ago and was really around the idea that we need to improve automation within our security operations for all of the things that I've talked about. Most importantly, improving the analytics that we're using for detection and response and doing it in an automated way, improving the reporting, and improving the orchestration. So when we do detect an alarm and we validate that alarm as, yes, this is a legitimate incident, how do we then react? With SOAR products, the idea behind it is that that response action could be orchestrated or automated so that something can be automatically done without the analyst ever having to take human intervention. So in answer to your question, and this is my opinion, Maria, I think AI is instrumental and is driving those SOAR products forward, or the SOAR capabilities within the platforms that are out there today. So a lot of SOAR capabilities have been merged into existing XDR, extended detection and response platforms. We consider our platform an extended detection and response. That just means that we are able to extend the capabilities around the data we ingest, the analytics, and the response actions we take. I don't think SOAR can move forward without AI. It's going to be instrumental, and it may, in my opinion, actually move those products closer to what they promised to be 10 years ago. As long as I've been in the industry, we've been talking about automated response actions. In our experience, in the company I'm with now and the company I was with before, which was a vulnerability management company where SOAR was very big as well, your security IT teams are hesitant to allow security teams to take automated actions without some kind of human intervention. With the use of AI, we may see that move forward, and I'm sure we will. So I think it'll just increasingly make possible a lot of those automated response actions that maybe we haven't seen as much in the past. Will it be possible in the near future AI can replace entry-level jobs or limit the vacancies of an operator in a SOC? And this is from Lashika University at Albany. I hope I pronounced your name correctly. This is a question that we get a lot. I think it's a question across the board about how AI may or may not replace jobs. I think right now within cybersecurity, we have a skill shortage, especially in the areas of threat detection and response, where there's a certain level of expertise that's needed for any security analysts. Within a security operations centers, you have different tiers of analysts. You have tier 1, tier 2, and tier 3 analysts. And that's really your tier 1 or your entry-level analysts who are doing kind of the entry-level mundane day-to-day work of monitoring the environment and checking on incidents and investigating things. So I do think that those lower level mundane tasks are going to be automated and are going to be replaced with AI, but I don't think that's a bad thing. I think what that's going to do is going to allow a lot of those vacancies that many organizations are struggling to fill to be closed up. And then the people that they do have, they're going to be able to train at higher, more complex things. I think AI, just like with any technology, it will definitely replace some jobs. It's not going to replace all. And keep in mind what I said earlier, that AI doesn't exist without a human, at least not right now. Who knows what it's going to be like 50 years from now. But we definitely need, at least at this point in time, people to be fine-tuning those algorithms, to be training those algorithms, and doing those higher level tasks. You cannot operate a SOC right now without humans. What else am I seeing? Let's see. There's a long question and I'm not sure what the person is asking. At what point is the cost of doing business online prohibitive and other methods of doing business should be considered? I work for a huge company, and between employees, technology, and fines, I wonder how any company can stay in business. Yeah, I mean, I think that's a larger existential question. I mean, I really think for us in cybersecurity, in my opinion, that is our job. Our job is to reduce that cost of doing business. which is why cybersecurity, in my opinion, and I think the opinion of my colleagues, has moved from the basement into the boardroom. It's moved from a technical challenge because of the growth of our digital economies, our digital communities. It's moved from a technical challenge to a business, even fundamentally organization, community challenge. You cannot think about city governments. If there's an interruption because of a ransomware attack, which we've seen a couple recently on a city government, it shuts down their services. It shuts down their ability to pay their employees. It shuts down their ability to serve their public. So our job as security professionals, which hopefully I think will create security within our profession for years to come, is to be able to reduce those risks so that that cost of business isn't so high. And therefore, I think anybody who is going into security is going into an area where, for at least the near future, you're not going to have to worry about a job. We are getting close to time, I think. And I think I answered, oh, one more question. Does anyone have access to OTX? Yes, the Open Threat Exchange, and we'll also send a link out to it. It is a completely free online community that's powered by the users and powered by Alien Labs, feeding validated threat intelligence back into that community. It is a gold mine for any organization. If you haven't checked it out, you should. It's a rich repository of information on malware, malware families, threat actors, IOCs. There's a lot of free functionality within the platform. You can actually integrate it with your own system and extract a lot of that threat intelligence into your own systems for use, for detection and response. You can create private communities in it, so you can use it almost like an ISAC if you want to communicate with your peers. So we'll make sure to share that. And the only thing that's required is that you provide an email and your name. I believe this presentation will be available. I know certainly it's going to be online. And then again, we'll make sure that we give that white paper that's available. I think I have answered all the questions that came into my chat, unless anybody wants to ask another question. All right. Well, I appreciate all of your time. I love WiCyS as an organization. I love the work that they're doing with women. We are a big advocate of women within our own organization, within AT&T Cybersecurity. In fact, one of the leaders of our Security Operations Center, a gal named Allison Cleland, rock star. She is one of the most powerful women I've met in cybersecurity, and she's just one example. We have others within our consulting organization, Bindu Sundaresan. So we're very, very happy to be a strategic partner to WiCyS and looking forward to doing more of these presentations and talking more with you all. Thank you.